at a low cost by maintaining high productivity. It is to be noted that some of these objectives are conflicting in nature with one another. To be in competition, modern industry must go for automation. Automation could be either fixed or flexible in nature, which are applicable to mass production and batch production, respectively. Robotics is an example of flexible automation. Therefore, modern industry should use various types of robots. To make a robot intelligent and autonomous, it should be able to capture the information of the environment accurately using the camera along with image analysis and or sensors. Have an adaptive path planner and or gate planner, adaptive controller, and others. AI tools have a great role to play in achieving these aims. Using fuzzy clustering algorithms is a viable option to extract useful information from a dataset associated with imprecision and uncertainty. Fuzzy C-means algorithm and entropy-based fuzzy clustering are two popular fuzzy clustering algorithms. Neither of these existing algorithms can develop both distinct and compact clusters. These inherent limitations can be tackled by employing an entropy-based fuzzy C-means algorithm. Cardiovascular autonomic neuropathy is the most common and clinically significant form of diabetic autonomic neuropathy, which is regarded as a serious and familiar complication of diabetes. The inherent imprecision and uncertainties associated with prediction and determination of the presence and severity of can can be efficiently tackled using the principle of fuzzy logic. The design parameters of the expert system are optimized using a particle swarm optimization offline. Now I will introduce our experts. Today, we are fortunate to have Professor Dr. Dilip K. Pratihar. He is Institute Chair Professor, Mechanical Engineering Department, IIT Kharagpur. Thank you very much, sir. We are really privileged for your presence this evening. Dr. Dilip Kumar Pratihar received his BE Honours and M.Tech in Mechanical Engineering from Regional Engineering College, now National Institute of Technology, Durgapur, in 1988 and 1994, respectively. He obtained his PhD from the Indian Institute of Technology, Kanpur, in 2000. He received the University Gold Medal, A.M. Das Memorial Medal, Institution of Engineers Medal, INSA Teachers Award 2020, New Code of Education 2021 Award, Distinguished Alumnus Award 2021 from the National Institute of Technology, Durgapur. Institute Chair Professor Award 2022 from IIT Kharagpur. Technologist of the Year Award 2022 from IEEE India Council. Faculty Excellence Award 2023 from IIT Kharagpur and others. You can think of what a learned professor we have this evening to share his wisdom with us. He was included among the world's top 2% scientists in the areas of image analysis and artificial intelligence in a survey carried out by Stanford University, USA. He was declared outstanding researcher at www.research.com. He completed his postdoctoral studies in Japan and then in Germany under the Alexander von Humboldt Fellowship Program, which is one of the most prestigious fellowship program in Germany. He received the Shastri Fellowship, Indo-Canadian Fellowship, to work on humanoid robots. Under his mentorship, a group of 4 students has received the Chanakya Fellowship recently by TIH IoT, coordinated by IIT Bombay, sponsored by DST, Department of Science and Technology, Government of India. He is working now as a professor in HAG IIT Bombay, HAG scale of IIT Kharagpur. He has made significant contribution to the fundamentals and applications of artificial intelligence in industrial automation, robotics, healthcare, education technology, and others. He has published more than 185 research papers in peer-reviewed international journals and more than 100 papers in conferences and national journals. He has contributed 26 chapters in edited international books. A few of his fundamental contributions published in IEEE, ASME, Elsevier, Springer journals are being highly cited by researchers in the field. His H-index values are found to be as follows: 43 Google Scholar, 30 Scopus, 29 Web of Science. He has written textbooks on soft computing, fundamentals of robotics, co-authored another textbook on analytical engineering mechanics, edited a book on intelligent automation systems, co-authored 4 reference books. He has developed 3 online NPTEL courses, such as traditional and non-traditional optimization tools, robotics, and fuzzy logic and neural networks. He has guided 25 PhDs, and 13 more PhD students are working now under his able guidance. He has filed 4 patents and received copyright for an intelligent optimization tool named Bonobo Optimizer. He has completed a number of sponsored projects funded by DST, DAE, DBT, MHRD of Government of India, and 5 consultancy projects of the industry. He has given his technologies like optimal design of leaf spring, the root causes of failure of the gas turbine unit, and industrial pipelines used to carry the fluid at high temperature and pressure. He is in editorial board of a few international journals. He is associate editor of 2 international journals. He has been elected as a fellow of Indian National Academy of Engineering, fellow of Institute of Engineers, MA SME, AMAAI, SMEI, EE. Then we have our second expert this evening, Mr. Bitan Pratihar. He is a research scholar, Chemical Engineering Department, IIT Kharagpur. Mr. Bitan Pratihar obtained his Bachelor of Technology degree in Chemical Engineering from the National Institute of Technology, Durgapur, in India in 2017. He completed his Master of Technology degree from the National Institute of Technology, Rourkela, India in 2019, where he received the Institute Silver Medal for branch topper in chemical engineering. Currently, he is a doctoral student in the Membrane Separation Laboratory of the Chemical Engineering Department, Indian Institute of Technology, Kharagpur. His research interests include artificial intelligence, controller design, soft sensor design for several chemical engineering applications, design and synthesis of novel materials for energy and environmental applications. He also has several publications under his name. This evening, we have moderator, our dear Chanchal Chakraborty. He is a BE MBA and has more than 35 years of professional experience in telecom and IT. He worked with flagship companies like CESC, NTPC, Department of Telecom, Bharat Sanchar Nigam Limited, and worked as Chief Technology Officer and Vice President in Aircel, Uninor, and Reliance Jio. He last worked as Vice President Technology in Reliance Jio. He has wide experience in planning, design, procurement, installation, and maintenance in all fields of telecom, written tech specification and standard on mobile communication. Currently, he is working as CEO of ATM Tower India Private Limited, a subsidiary of ATM Denmark. He has participated in several national and international seminars, including GSM Congress at Cannes, France, Bug for international roaming. He has received different accolades, including the Bisist Sanchar Seva Award from the Ministry of Communication, Government of India. He published papers in IEEE and holds patent. He is a fellow of IEI and Secretary ISA USA, Kolkata section. He is a team player and he loves to serve society to the best of ability. This is the brief introduction of our learned speakers and my dear friend Chanchal. So over to you, Chanchal. Please carry it forward.
Thanks, Ramda. Now we invite Dr. Pratihar, Dilip Kumar Pratihar, and Bitan Kumar Pratihar for giving the lectures on the today's main topic, AI and robotics. So over to Dr. Pratihar. We are eager to listen from you.
Okay. Good evening to all of you. Now, before I start, I express my gratitude to the Institute of Engineers, India, West Bengal State Center, Electronics and Communication Engineering Division Board, particularly Dr. Chanchal Chakraborty for taking the initiative so that I could speak in front of you. I am grateful to my employer, IIT Kharagpur, for giving me the necessary approval for delivering this lecture. Now, today we'll be discussing on AI and robotics, like the fields in robotics where we could use the principle of AI. Now, let me just share my PPT. Is my PPT, can you see my PPT?
Yes, yes, yes.
Hello?
Yes, Dr. Pratyar, we can
Hello?
listen to you. Yes, it is visible.
Hello?
Dr. Pratyar, it is visible.
It's visible, no? Can you hear me
Yeah.
also?
Yes, 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 we can listen to it
Take it,
also.
take it, take it. Okay, okay. Just a minute. So my voice is audible and you can see my PPT.
Absolutely.
Hello?
Yes, yes, we can listen
Hello?
to you. Yes, yes.
Hello?
Hello, we can listen to you.
Acha. So you can listen to me and PPT is also available, no? You can see the
Right.
PPT. Huh.
Right.
Oh,
But as soon as it goes on the presentation mode, then
huh.
whenever we.
Hello?
Hello.
Hello? Just
Ha.
a minute. I think there is some problem. Now, can you hear me?
Yes, we can hear you.
Hello?
Hello, we can listen to you, Dr.
Okay.
Pratyar.
So my voice is audible and your slides are also visible, no?
Right, right.
Yes, sir. Perfectly.
Hello?
Perfect. Perfectly,
Yes, sir. We
perfectly.
can hear you,
Hello?
sir.
Hello?
We
Hello,
can
hello,
hear you,
yes.
sir.
Actually, Dr. Pratyar, the problem comes as soon as you are going on the presentation mode,
There
your
is some
voice.
problem, no?
Yes, 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 yes.
We can hear you.
Rather you can move with this. Go on.
Acha. So is it okay? Is it okay?
Yes,
Absolutely.
sir.
Okay, okay, let me proceed with this. So I'm going to talk on AI and robotics. So the title of my talk is AI and robotics. Now this is the structure of my talk. Now I'm just going to start with the very definition of the term intelligence. Like, what do you mean by intelligence? And when can we call that a person is intelligent? So I'll try to find out the difference between the human intelligence and artificial intelligence. I'll try to see whether AI can beat human intelligence and vice versa. And the different areas of artificial intelligence, I'm just going to discuss in short. The merits and demerits of AI, that also I'm just going to touch upon. I'm also going to give a brief introduction to the concept of the computational intelligence. Now, this artificial intelligence has been used in various fields. So those things I'm going to discuss briefly. And I'll try to understand that why should I go for the concept of robot and robotics in modern industries. And all of us, we know that besides industries, nowadays, the robots are used for various purposes. Like we are using robots for underwater mining. We are using robots in medical science, space science. And what is the reason behind going for the robotics? That I'll try to find out. The working principle of the different types of robots, the different components of a robot will be discussed in short. And we'll see that there exist the different types of AI tools. And I'll give a brief introduction to the AI tools. And from those AI tools, I'll try to find out a few which could be used to design and develop the intelligent and autonomous robots. And a few robots developed by us will also be discussed here in today's presentation. So let me start with the first query, that is, what is intelligence and why do we call a particular person an intelligent? The concept of intelligence is very old. So, from the ancient times, like the Greek civilization, Egyptian civilization, so this particular term intelligence was introduced. It was then used by Aristotle, Rene Descartes, Thomas Bayes, and others. Now, in the year 1956, the first proposal on AI that was submitted, and it was on Bayesian logic. And then in the year around 1994-95, the DARPA project was sanctioned. And the purpose of DARPA project is to develop the intelligent robots. Now my question is, when can you call that a person is intelligent? A person is called intelligent if he or she can take the decision as the situation demands in an adaptive way. Now, we had heard about the intelligent system, autonomous system, and truly speaking, all the intelligent system, all the intelligent system may not be autonomous, but all the autonomous system must be intelligent. Now, let me take a very simple example. Now, in our education system, we have got the university system, we have got the autonomous institutes. Now, if you consider one autonomous institutes, like say IIT, NIT, here, this institute consists of a large number of intelligent people. So this autonomous system consists of a few intelligent people. On the other hand, if I consider the institutes which are working under one university, so those institutes consist of a large number of intelligent people, but many decisions they are unable to take. They'll have to depend on the university rules. So there, the people are intelligent, but this particular, the institutes are not autonomous. They'll have to follow the rules and regulations of the university. So all the autonomous systems must be intelligent, but not all intelligent systems are autonomous. So we can develop the intelligent robots, we can develop the intelligent and autonomous robots. The point which I'm going to make, that all the intelligent robot may not be autonomous, but all the autonomous robots must be intelligent. Now, with this particular concept, I'm just going to define the term artificial intelligence. So, what do you mean by artificial intelligence and how does it differ from the human intelligence? Now, here, actually, the artificial intelligence is incorporated to the head of an agent through some training through some learning. And this particular agent has got some very powerful sensors. So those sensors are used while giving training, while giving teaching to that particular agent. So that particular agent can act as an intelligent agent. That means the artificial intelligence that will be incorporated to the head of the agent. Now, to find out the difference between the artificial intelligence and human intelligence, let me try to take one example. Now, supposing that one undesired incident has occurred at a place. Supposing that there is a murder case. So, if there is a murder case, then investigation will start and the policeman will try to find out who could be the possible murderer. Now, supposing that the policeman could solve the problem, the murderer could be identified, so the problem is solved. And supposing that the policeman could not solve it, then what will happen? The policeman is going to take the help of a sniffer dog. Now, dog has got very strong smell sensor, and this particular sniffer dog is trained by the policeman. So there is a possibility that this particular sniffer dog is going to find out the possible murderer. Now you see, the policeman could not solve the problem, but the sniffer dog trained by the policeman could solve that particular problem. So if we say that the policeman is having the human intelligence and the sniffer dog is having the artificial intelligence, here the artificial intelligence could defeat the human intelligence. Now let me take another example. Supposing that I'm just going to give a very simple mathematics, like 10 plus 5 equals to how much? Now, if I just ask the policeman will be able to give the answer. But if I ask the same question to the sniffer dog will not be able to give answer because the sniffer dog was not trained. Now, here in this particular example, the human intelligence could beat the artificial intelligence. The point which I'm going to make, I'm just going to find out the difference between the human intelligence and artificial intelligence. And in one task, the human intelligence could beat artificial intelligence. And in another task, AI could beat HI. So we should not compare and try to come to the conclusion that whether AI is stronger than HI and vice versa. So the point which I'm going to make, it depends on the task. If required, we'll have to use AI or we'll have to use HI or sometimes a combination of HI and AI to solve that real world problem in a very efficient way. Now, if you see the literature, we have got 4 different types of AI. For example, we have got the reactive machines. Now, these reactive machines are AI without memory. Now, we may have heard about that IBM's Deep Blue, that is an expert system. And this particular expert system could beat Gary Kasparov in chess playing in the year 1997. This is a very good example of a reactive machine. You might have also heard about the driverless car, which is nothing but another type of AI, which is the AI with limited memory. Then comes in robotics, we try to design intelligent robots, autonomous robots. We also try to design and develop the emotional robot. Now, how to incorporate this emotion of a human being to the head of a robot? We'll have to do the modeling of the emotion of a human being. And we'll have to incorporate the emotional modeling to the head of a robot. And that is also another type of AI that is called the theory of mind. Now, the fourth type of AI is AI with self-awareness, which deals with the consciousness. Let me take a very simple example. Supposing that I have got the ability to perform a particular task, but I am not working hard. Supposing that I have become lazy. Now, if I have got the opportunity to do something, and if I have got that particular ability to do something, but I'm not doing, now my awareness or the consciousness is going to tell me that although you have got the ability, you are not working hard. So that type of AI is nothing but the AI with self-awareness or the AI with consciousness. So this particular AI is actually still in the research phase. Now, if you see the literature, nowadays, the principle of AI is used in different fields like healthcare, the business, education technology, finance, law, manufacturing science like in automation, machine vision. AI is used in banking, transportation, natural language processing, speech recognition, sentiment analysis, drug design, human facial recognition, and others. Now, this particular AI has got a few merits and demerits. Now, it has got a merit in the sense that from the data, the available data, it can extract the useful information. That means the real world complex problem we can solve, and we can also find out the consistent results. But it has got a few demerits. Demerits in the sense this AI tools most of the times becomes computationally expensive. It requires the deep technical expertise to develop the AI tools, and we may not get the sufficient number of qualified people who could work in the field of AI to develop the various AI tools. And this particular AI actually tries to model the processing of a human being. That means it will try to copy the behavior of a human being to solve some problem. But it does not try to explain the processing or the method of brain processing. So these are all merits and demerits of AI. Now, if you see the literature, a large number of tools are available, and those are called the AI tools, which I'm just going to discuss after some time. But before that, let me try to give you another concept which is also very popular. That is the concept of the computational intelligence or CI. Now, this computational intelligence, by definition, it is actually AI using the principle of the soft computing. Now, this particular soft computing, which was proposed, that particular term was proposed by Professor Jade in the year 1992. It deals with or nature-inspired tools. So, nature-inspired tools for optimization, nature-inspired tool for learning and adaptation, nature-inspired tools for modeling imprecision and uncertainties. All such tools are combined under the umbrella of soft computing. And AI using soft computing, that is considered as the modern AI tools are nothing but the computational intelligence tools. Now, if you see the literature of this computational intelligence, and I can also call it after some time, I'm just going to use that particular term. These are all machine learning tools. Works based on the principle of biological adaptation. It works based on the evaluation tools, learning tools, and all such things. So I'm just going to tell you in short the principle of the biological adaptation. Now, all of us we know that complex real-world problem is very difficult to model and very difficult to design and fabricate. So we try to see the way our nature has evolved those systems without going for the direct design or the explicit design. So we can see that the principle of biological adaptation. In biological adaptation, we use two terms. One is called the learning, another is called the evolution. Now, so long as we live throughout our life, we learn many good things. And if I could learn something good, we try to pass it to the next generation. That means we pass it to my students, my son. If I have learned something new, and this particular information, the good information, the good knowledge is going to increase the rate of evolution. So the rate of evolution will be accelerated. Now, this particular learning is going to help in evolution. So now, on the other hand, during the learning, knowingly or unknowingly, we use the principle of optimization. And if you see the way one optimization tool works, we use the principle of evaluation. So iteratively, this particular optimization tool is going to find out the optimal solution. So during this learning, we use the principle of evaluation. So this learning helps in evolution, and evolution in return also helps in learning. So they are going to help each other, and that accelerates the principle of your the adaptation. So we can increase the rate of biological adaptation through a proper combination of this particular the learning and evolution. So exactly the same thing we do whenever we consider the computational intelligence. Whenever we try to evolve this particular computational intelligence, we use the principle of learning and evolution. Now, if you see the literature, we have got a varieties of evolutionary tools, and those are nothing but the meta heuristics or biologically inspired optimization tool like genetic algorithm, genetic programming, evolution strategy, evolution programming, and there are many others like vertical swarm optimization, and we have also proposed bonobo optimizer. Now here, if you see these evaluation tools, we try to find out only two things. These are all iterative method. So we try to find out the search direction and how much should be the step length at each of the iteration. Now, if you see genetic algorithm, that is one of the most popular evolutionary tools. It does not has the memory, so its search capability might be good for the global search, but its local search capability may not be good. Now, in the year 1995, PSO was proposed, and this PSO has got memory. So, as it has got the memory, it could perform even better than genetic algorithm for the complex optimization problem. Now, in the year 2019, we could propose one new technique that is nothing but the intelligent optimization tool called Bonobo Optimizer. It has got memory, it has got intelligence. As it has got both memory and intelligence, so this Bonobo Optimizer could find out the optimal solution for a complex problem very easily, and its search speed is pretty good. Now we have got a few learning tools in our brain in the form of neural networks, in the form of fuzzy reasoning tool. So these neural networks or the fuzzy reasoning tool can be used as the learning tool. So we try to capture the information with the help of network like neural networks or with the help of fuzzy reasoning tool. And then we take the help of some evaluation tool just to find out what could be the soft computing tools or computational intelligence tools or machine learning tools, and in the form of the genetic fuzzy system, genetic neural system, neurophagy system, and genetic neurophagy system. And once these machine learning tools are designed and developed, we could solve the real world problem, the complex real world problem very efficiently. Now, if you see the literature of AI tools, as I told, there exists a large number of tools. For example, we have got a few heuristic techniques. Now, these heuristic techniques may solve the problem, but there is no guarantee. So, there is no guarantee whether we'll be getting some solution for the problem or not. There are a few search algorithms like depth first search, breadth first search, and so on. There are hill climbing search like gradient based search. Symbolic logic is also used as AI tools. The conditional probability for handling uncertainty and imprecision, that is also another very efficient AI tool. And of course, we have got a large number of meta heuristics. These are nothing but the nature inspired optimization tools. As I mentioned a few minutes ago, we have got a few input output modeling tool in the form of fuzzy logic, in the form of neural networks. We can also design and develop some clustering tools based on the similarity, some classification tools, and of course, we sometimes need the dimensional reduction technique because we human being, we can visualize only up to 3 dimension. If the data is there in 4 and a higher dimension, nobody can visualize. So this higher dimensional data are to be mapped for the purpose of analysis using the dimensionality reduction technique. There are a few other tools also. Now here if you see, if I consider that this particular circle indicates all the AI tools, so these machine learning tools are subset of that AI tools. So just outside of the machine learning tools, there are a few other tools which can also be called the AI tools. And within this machine learning, we have got the deep learning neural network. So all of us nowadays, we hear about the deep learning network. And this particular deep learning network is actually the tool with the help of which the AI has become today's AI. Now, as I told, the concept of AI started around 1956. And suddenly we could see that there are many such applications of AI tool. But due to some reason, so this AI tool, actually its popularity started falling in nature, I should say. Then with the introduction of this particular deep learning network, so AI has become today's AI. And this particular deep learning network is actually a special type of network having more than 2 hidden layers. So besides the input layer and the output layer, we have got more than 2 hidden layers. But remember, each of this particular hidden layer is going to perform a particular task. That means it is going to perform or going to capture a particular the pattern. The point which I'm going to make here, that all the neural networks having say 3 or more than 3 hidden layers may not be called as a deep learning neural network. So deep learning network is that particular neural network which is having more than 2 hidden layers, and each of the hidden layers is able to capture a particular the pattern to solve the real world complex problem. So this deep learning network is the subset of the machine learning tools. And nowadays, we hear too much about this generative AI. That is nothing but the Gen AI. And that is also a subset of this particular, the deep learning network. So this generative AI is a special class of deep learning network which could also learn, collect some data while working. So what we do is we give some offline training to the deep learning network, and this particular deep learning network is going to solve some problem. And while solving that particular problem, it is collecting some additional training data. And with the help of that particular training data, it is going to train once again. So there will be online training, and that is the principle of today's generative AI. So nowadays, this generative AI has become very popular because it could solve the difficult real world problem in a very efficient way. Now, with this little bit of like introduction to the principle of AI, I'm just going to quickly start with the introduction to robots and robotics, and I'll try to establish the fields where we could use the principle of AI in robotics. Now, before I go for this robot and robotics, let me try to understand that why should we go for robotics? What is the reason that most of the modern industries are going for the robots? Let me try to understand that particular the thing. Now, all of us we know whenever we are in business, so a particular industry is in business, so this industry is going to survive for a long time. It is going to earn some profit, and to do that, this particular industry will have to compete with the dynamic and competitive market. Now, if you want to be in the dynamic and competitive market, the three things we'll have to do. The manufacturing unit or the modern industry should try to produce the good quality product at the low cost, and at the same time the productivity has to be high. Now you see, I'm considering the three objectives like maximize the productivity, improve the product quality, and minimize the cost of production. So these three objectives are conflicting in nature. They are going to fight with one another. Now, if you want to survive and if you want to earn some profit, if you want to be in competition, so the modern manufacturing unit should go for the robots because robotics is an example of automation. Now, this particular modern industry, to be in competition, they'll have to go for automation. And if you see the literature, we have got, in fact, two different types of automation. One is called your the hard automation or the fixed automation, which is suitable for the mass production when a particular product, a particular design is produced in very large in number. On the other hand, there is a concept of your flexible automation where a few designs are to be produced, a few in number, and there we'll have to use the principle of flexible automation, and robotics is an example of flexible automation. So whenever there is a batch production, we can go for the robots and robotics. But for the mass production, we'll have to go for the hard automation. There we can go for the hard automation, but it's better not to go for the robotics. So the robotics is suitable for the batch production. Robotics is an example of the flexible automation. Now, if you see the history of robots and robotics, the word robot that was actually introduced in the year 1921 by Karel Kapik. He wrote one drama. The name of the drama was Rossum's Universal Robots. So Karel Kapik actually described a robot is nothing but a leveler or a forced leveler. That means it is just like a servant. So you give some task to the servant and the servant is going to perform that particular task. But remember, in the year 1921, there was not even a single robot in the world. The robot was first developed. The first robot was developed in the year 1954. Okay. And this particular term of robotics was coined in the year 1942 by Isaac Asimov. So in the year 1942, Isaac Asimov wrote one story. The name of the story is Run Around. And in that particular story, he introduced the term robotics in the year 1942. Now you see, that time also, in the year 1942, there was not even a single robot in the world. As I told, the first robot that was made in the year 1954 by George Devil. And George Devil is known as the father of the robot. Now, if you see robotics, and if you want to be the true roboticist, we should have the fundamental knowledge of physics, mathematics, mechanical engineering, electronics engineering, electrical engineering, computer science, and others. And that is why it is a bit difficult to become a true roboticist. Because in robotics, there are four distinct modules like kinematics, dynamics, control scheme, and communication scheme. And we have got the intelligent issues. We'll see that the kinematics, the purpose of kinematics is to make the movement at the different robotic joint, and the purpose of dynamics is to find out what could be the capacity of the motor which are going to put at the different joints of the robot so that this particular joint can provide the necessary torque if it is a rotary joint, or the necessary force if it is a linear joint. That is the purpose of your the dynamics. So the kinematics and dynamics are coming under the umbrella of mechanical engineering. Now, in robotics, we'll see we take the help of the camera, the image analysis. We try to take the help of the multi-sensor data fusion, because in robots, we use different types of robots. And we'll have some sort of control scheme for the motor. Generally, we use PID controller, adaptive PID controller, different other types of recent controllers we use. For example, fuzzy sliding mode controller, inverse dynamics controller, model reference controller, and so on. So there we'll have to study the control scheme, and definitely we'll have to take the help of communication scheme, and that comes under the umbrella of electrical and electronics engineering. And then we'll have to incorporate intelligence to the head of a robot. We'll have to incorporate the emotion to the head of a robot in the artificial way. There we'll have to take the help of computer science. So if anybody wants to become the true roboticist, that particular person should have the strong fundamental knowledge in physics, in mathematics, in mechanical engineering. Then comes your electrical, electronics, computer science, and so on. Then only one can become the true roboticist. Now, if you see construction wise, a robot is nothing but a collection of a few links, and two links are joined by a joint. Here you can see that in this schematic view, say we have got one link here, another link here. In between, I have got a joint. Now, this robotic joint could be of two types. It could be either linear joint or there could be rotary joint. The linear joint could be either sliding joint or the prismatic joint. The rotary joint could be either the revolute joint or the twisting joint or the universal joint or the spherical joint. Now, the spherical joint has got 3 degrees of freedom. Universal joint has got 2 degrees of freedom. Revolute joint has got your, this is actually an example of revolute joint. It has got 1 degree of freedom. Here we have got one rotary joint that is called the twisting joint. It has got 1 degree of freedom. There is no linear joint here. So if you use a linear joint like sliding joint or a prismatic joint, each will have 1 degree of freedom. And to generate that particular movement along that particular the degree of freedom, we need a motor. So at each of the robot, we'll have to fix a motor, and this particular motor has to be controlled by a controller. And here you can see this is the schematic view which is showing the drive unit. Now in robotics, we try to copy everything from the human being. For example, we try to copy the hand of a human being. We try to copy the head of a human being using the principle of AI. We try to copy the heart of a human being. That is nothing but the emotion of a particular the human being. And of course, the decision or the planning that is taken in the controller or the director. And to execute that, we try to take the help of this particular drive unit. Drive unit could be either pure mechanical, it could be hydraulic system, it could be pneumatic system, it could be electrohydraulic, it could be electropneumatic. So there could be different types of the drive system. Now, if I compare with our human body, we have got the muscles. The muscles are going to provide some mechanical power. We have got the blood, that is nothing but the hydraulic system. The pressure is generated by the heart and it is circulated. So our actually the drive unit for the human body, it is a combination of the mechanical muscles and the hydraulic system, where hydraulic fluid is nothing but the blood. Now, here, a typical robotic system consists of a few links, as I told, a few joints. At each of the joints, there will be motors. Motor will be connected to the controller, and there must be sensor to collect information of the environment. There could be different types of sensor. There are a few internal sensor, a few external sensor. We try to take the help of camera. With the help of camera, we collect information of the environment and we do processing. Now I'm just going to discuss the areas where the principle of AI could be used in robotics. And remember, all the AI tools may not be applicable in robotics. And as I mentioned, that there are 4 modules of robotics. Out of these 4, the first two modules, that is kinematics and dynamics, there is no scope for using the principle of AI. So AI is to be used on control scheme, on communication scheme. It has to be used to incorporate intelligence to the head of a robot. Now here I'm just going to show you a few the robots available in the market. This is nothing but how to model the hand of a human being in the mechanical way. So this is nothing but a serial manipulator called UR5 manipulator. This is another industrial robot, the KUKA robot. This is also a serial manipulator. This is nothing but a wheeled robot, two-wheeled, one-caster mobile robot. And this particular robot is manufactured by Micro Robot in Singapore. This is a 6-legged robot, the schematic view of a 6-legged robot, look-wise similar to a spider. Here I can show you some wheel robot. We have also developed some wheel robot for a railway track inspecting. And we have filed patents also. This is actually the line following robot. This is a tracked vehicle. Now similar type of robot we have modified further, and we have designed and developed the tracked vehicle as the agricultural robot, for which also we have filed the patent in the year 2023, this year only. Now this shows the 8-legged robot just like an insect, the 6-legged robot like an insect, the 4-legged robot like an animal, and we have also got the 1-legged hopping machine also. And this is only dynamically balanced. We have also got the humanoid robot, like now we have got in our Center for Robotics, IIT Kharagpur, we have got the now robot having 25 degrees of freedom. So these are actually the different types of robots available in the market, and these are the references for different types of robots which I discussed. Now a few things which I'm going to discuss here. The fields where we could use the principle of AI. Now these are the things which I've already mentioned: kinematics, dynamics, sensing, then control, then the areas of motion planning, artificial intelligence, which are coming under the purview of computer science, electrical and electronics like control scheme, hardware implementation for the robots. Now I'm just going to concentrate more on the role of AI in robotics. Now, as I told, that in the modules of kinematics and dynamics, we cannot use the principle of AI. Okay, and AI are to be used where to collect information of the environment using the camera and image analysis. So in digital image analysis, there is enough scope of using AI, and nowadays we people use very frequently to carry out this particular image analysis using the principle of the deep learning network, neural network. So we can also use the concept of AI to carry out the multi-sensor data fusion to collect information of the environment. Now today, the second speaker, Mr. Bitan Pratihar, he is going to talk on after some time, like how to use the principle of AI, the fuzzy logic, the fuzzy clustering, fuzzy reasoning, just to collect or just to extract the important information regarding that particular environment. So this particular multi-sensor data fusion will be discussed by Bitan after a few minutes. Now, we can use the principle of AI to develop the adaptive motion planner, which will help us to take the decision as the situation demands. So this AI is also going to help us to develop the adaptive gait planner for the multi-legged robot or the humanoid robot. And this gait is nothing but the sequence of leg movement in coordination with the body movement so that the robot can perform some pre-specified task. I'm just going to take one example, very practical example after some time. Now, this particular AI can also be used to develop the adaptive controller. Now, all of us, we know that if we use some PID controller along with the DC motor, so in closed loop fashion, if I want to use that PID controller, that is the proportional integral derivative controller, so I can use it provided I know the fixed values for this gain, that is your Kp, Ki, and Kd. That is the proportional gain, integral gain, and derivative gain. Now, how to find out the suitable numerical values for this Kp, Ki, and Kd? There are some standard methods. And out of all the methods, the most popular one is the method which is known as the Ziegler-Nichols method. So using the Ziegler-Nichols method, we can find out what could be the adaptive values for what could be the fixed values for this Kp, Ki, and Kd. But supposing that the robot is working in a highly dynamic environment. So if the environment is dynamic in nature, so this particular PID controller with this fixed predetermined values of the gain may not be suitable. I'm just going to take a very practical example. After a few minutes, you'll see that this particular PID controller is going to fail. And we'll have to go for the adaptive PID or some other type of PID adaptive controller, like as I told, the model reference controller or the dynamics, inverse dynamics controller, or the fuzzy sliding mode controller. So that type of adaptive controller we'll have to go for. Then AI can be used to model the emotion of a robot also in an artificial way. All of us, we know, we human beings, we are intelligent. We are emotional too. So any decision taken by us is a combination of intelligence and emotion. Now, the moment I'm just going to replace one human being by a robot, the robot has to be intelligent, the robot has to be emotional too. Now, let me take a very simple example and we'll understand that without the principle of AI, we can't do much. We can't use these particular robots very efficiently. Let me take a very simple example. Now, all of us, we know that there exist different types of robots. Let me just let me just try to collect the names once again. For example, we have got the manipulators. Manipulators are nothing but the robot with fixed base. Now, these manipulators, just like our mechanical hand, it could be serial manipulator, or there could be parallel manipulator also, like Stewart platform. Okay, so the load carrying capacity of the parallel manipulator will be much more compared to the serial manipulator. We have got different types of mobile robots. For example, we have got the wheeled robots. If the terrain is smooth, if the terrain is very rough, there are some ups and downs, staircases. We'll have to go for the multi-legged robots, like six-legged robot, eight-legged robot, four-legged robot, two-legged robot like human being. There could be the terrain which is not so much smooth, which is not so much rough, it is in between. And there you can use your some sort of the tracked vehicle. For example, the agriculture robot which we have designed and developed in our Center for Robotics, IIT Kharagpur, is your the tracked mobile manipulator, which could also work in your the real paddy field. Now, let me once again come to that particular the conclusion that out of all the robots available in the market, the most difficult one to design, develop, and use is nothing but the humanoid robot. All of us we know that our human body is the most complex one in the world. Okay, and so out of all the robots, the most difficult one is the humanoid robot. And this particular humanoid robot will have to perform a variety of tasks. Let me take a very simple example. Supposing that I'm just going to replace the human soldier by a robotic soldier. Now, this robotic soldier, once it is there in the field, its design is kept fixed, its kinematics is known, dynamics are also known, and after carrying out the kinematic analysis, dynamic analysis, after carrying out its optimization, we reach to the optimal design of the robot. And based on the optimal design, we have already designed and fabricated one humanoid robot. And this particular robot is there in the real field. That means in the real field, say the robot is carrying a bag having a few things like food, water, medicines. There could be some ammunition also. There could be some instruments, okay, just to fight in the field. So all such things the humanoid robot is going to carry, and the real field could be too much, could be full of ups and downs. There could be rough terrain. Now you see the kinematics is fixed, the dynamics is fixed, design has been done, robot has been fabricated, and in the working condition, the robot is actually facing the dynamic environment, different types of scenarios, different types of situation, different position. Now it is actually the AI of the humanoid robot which is going to help to take some decision so that this particular soldier is going to work in the field efficiently. What are those? This particular humanoid robot should have the adaptive motion planner so that it can take the decision as the situation demands. It should have the adaptive gait planner so that it can modify the walking pattern as the situation demands. It should have the adaptive controller so that this particular the motor connected at the different joints can provide the necessary torque, and at the same time the whole robotic assembly should be able to maintain its dynamic balance. And all of us we know, we human beings, we are not statically stable. We may not be statically stable. We are always dynamically stable. Even if we are standing at a particular location, you forget about the walking. forget about the running. Whenever we are standing at a particular location, we are dynamically balanced. And our body can balance our system can maintain the balance of the body because we have got in our brain adaptive motion planner, adaptive gait planner, adaptive controller, and of course we have got the adaptive emotion planner. Okay, so all such things are working and they are going to help that particular robotic soldier in the field. And of course, this particular robot is going to collect information of the environment with the help of the cameras and or sensors mounted on it. So we have understood, I hope, the role of AI in robotics. Truly speaking, so out of the four modules, so the first two modules like kinematics and dynamics, there is not much role. Kinematics, in fact, there is no role of AI. It is totally mathematical. In dynamics, in general, whenever we are using the standard Lagrange Euler formulation or recursive Newton Euler formulation, there is no application of AI in dynamics. But there is one very current field of doing dynamics that is called the multibody dynamics. So if you are going for multibody dynamics, so there could be a chance of using AI. Now, let me tell you, this multibody dynamics in robotics, not much study has been carried out. I guided one PhD thesis on multibody dynamics for a six-legged robot, and that particular thesis could also be published in the form of one Springer volume, one reference book. But till today, to the best of my knowledge, not even a single paper has been published on multibody dynamics of a humanoid robot. It is extremely difficult problem. There could be a chance that we could use the principle of AI to carry out the multibody dynamics analysis for a humanoid robot. So, not no work has been actually carried out to the best of my knowledge till today. Now, with this little bit of introduction to the principle of AI, the human intelligence, computational intelligence, the different types of AI tools, and the different types of robots, and we have also found out a few areas where the principle of AI can be used in robotics. I'm just quickly going through a few robots which we have developed at our Center for Robotics, IIT Kharagpur. But a few robots I'm not going to show because those particular robots for which the file, the patent has been filed, it is still under examination, a few robots. So those pictures actually I'm not going to show it, but other pictures I'm going to show. So this is actually one robot that is called a legged mobile manipulator. You can see that it has got, this is nothing but a six-legged robot. At the top of that, I've got a serial manipulator like a robotic hand. With the help of this particular robot, we can solve some industry problems like the problem for which we developed how to separate out the floating slag on a molten metal bath. So before that particular molten metal bath goes for solidification, the slag, that is the impurity, those are to be separated out. We can also use this type of robot even for cleaning the floor of our lab space. Okay, so there are some applications. Now here, I'm not going to show you the actual picture of the agriculture robot. That is almost similar to a tracked mobile manipulator. Tracked mobile robot I have already shown. After that, we put some serial manipulator and we could design and develop one agricultural robot. Okay, now this particular agriculture robot can actually collect information whether the plant's leaves are suffering from any disease through image analysis, and it can take the decision whether the plant is suffering from disease A or B or C. And accordingly, we have got the provision of spraying pesticide. And this particular robot is going to select the appropriate pesticide and it is going to spray that particular pesticide in the real field. So by doing this, actually, we are going to do some sort of help to the farmer because the pesticides are actually not suitable for human body and it is in fact the dangerous for the human body. So the farmers are afraid of spraying different types of pesticides. So this agriculture robot is going to replace that particular the farmer in the field. And recently we have got one project under the Chanakya Fellowship. So this particular robot, we are further modifying it so that we can do some sort of your fruit speaking, watering problem. So we are modifying this particular the agriculture robot further. We have filed the patent in this particular year only. Another patent we have filed on railway track inspecting robot. So this particular robot is equipped with camera. So with the help of camera, it will take the snap of the picture of that particular the railway track. We do image analysis. We try to find out if there is any such cracks on the railway track. And if there is a crack or some other defect, what could be the possible location with the help of GPS? What could be the possible location of that particular robot and that particular crack? So this robot can be remotely controlled. Recently, we are modifying this particular design, and we are trying to now design and develop some railway track inspecting robot which could be used in the real field of railway track inspection. So we filed the patent in 2019. This is one drone which has been developed by one of our PhD student, Anand Ronald, in our Center for Robotics. And now we are modifying this. We are also going for the current version or the recent version of other type of drones also. So these drones can be used for different types of inspection job. This is the orthotic device which we have designed in our lab. This is the outcome of one PhD thesis where this type of orthotic device was designed, developed, and tested just to give some support to the disabled people, the old people. This is one another prosthetic device which you have developed, and this is just like your amputee. Supposing that the part of a limb has lost, and we can use this type of prosthetic device, and it has also been tested, and we got wide publication from this particular work also. Uh, there are a few other robots like pipe climbing robot, wall climbing robot on which we are working. And there are some other types of robots. Like there is one robot which is nothing but a robot sort of thing. And there are a few others. Okay. So I'm not going to discuss because time is short. Uh, so with this little bit of introduction, so I'm just going to give a summary of whatever I discussed today. Now, if I can remember, I hope I'm able to give reply to the few queries. So those queries, I'm just going to tell you one after another. For example, I tried to find out what do we mean by intelligence? How can you call a person intelligent? Then we tried to find out what is artificial intelligence and how does it differ from the human intelligence. Can AI beat human intelligence or vice versa? Then we introduced the concept of the computational intelligence, the principle of soft computing to develop the modern AI tools, which are known as the machine learning tools. Then we discussed in brief the principle of the deep learning network, that is actually a subset of your the machine learning tools, and we also discuss a little bit on generative AI. We discuss the different types of AI. We try to find out the different applications of AI, then the merits and demerits of AI. What are the different types of AI tools? Then we try to concentrate on the why should we go for robotics? What are the special purpose or the reason behind going for the robotics? And I started with the very introduction of the term robotics, the different components of a robots, different types of robots, different applications of robots. And then we try to find out all the AI tools available in the literature. And we saw that all the AI tools may not be applicable to robots. And in robotics, there are 4 modules. Out of 4 modules, we cannot use the principle of AI in kinematics and dynamics. However, in control scheme and intelligent issues, there is no way out, but you'll have to go for the principle of AI if you want to design and develop the intelligent, autonomous, and emotional robot. So all such things I discussed in short. And then we give a brief introduction to a few robots, but not all developed by us till today. So I could summarize the things which I discussed today. These are some of the references. The textbook written by me on fundamentals of robotics. This particular book was published in the year 2017, both in India and UK by Narosa Publishers. And recently, this book, its modified version, has also come. And the name has been changed like the fundamentals of robotics and artificial intelligence. So this could be, there might be the first textbook where the principle of AI as well as the principle of robotics has been discussed in one textbook. So this has come in this particular year, 2023. Then comes the textbook on soft computing, as I told, that is the heart of your current AI tools or the modern AI tools. So this textbook was written by me in the year first in 2008, the first version. Second version was published in 2014, and the first version was published both first and second from both India and UK. And this particular soft computing was also translated into Chinese language in the year 2009. And now in this particular year 2023, its modified version has come. Now I have got 3 NPTEL courses already running and rerunning for the 5th or 6th times. Out of that, the NPTEL course on robotics is found to be very popular. Then NPTEL course on physiologic and neural networks is also popular. Then another NPTEL course that is on traditional and non-traditional optimization tools. Now, within a few days, I'm going to develop my 4th NPTEL course, and that is very special in the sense that could be the first and only available NPTEL or the online course on experimental robotics. So to the best of my knowledge, there is no such online course on experimental robotics, which will be developed by me within a few days. So I'm just going to start my recording within a few days. And in that particular NPTEL course, there will be 5 experiments. So 5 experiments will be conducted on 5 different robots. The first one is on serial manipulator, how to teach a robot, how to give instruction. The second experiment will be on the agricultural robot, how to control it, how to do the navigation, how to solve the different types of purpose in the real field. The third experiment will be on a six-legged robot, how to control it so that it can trace one predetermined trajectory, or it can perform that particular task. The fourth experiment will be on drone, like how to navigate a drone. And the fifth experiment will be on humanoid robots. So we have got one humanoid robots. It is an intelligent robot, 25 degrees of freedom now robot. And with the help of that, we are going to conduct some experiment. So we are going to actually develop the new NPTEL course. That is my fourth NPTEL course on experimental robotics. Another thing I just want to tell you that only a few weeks ago, I could also develop one course on robotics and artificial intelligence for the school children, starting from class 9 up to class 12. And there we did not use the principle of higher mathematics. So I took the help of a few story. So with the help of that particular story, I could develop one course, and that was organized by Ramakrishna Mission Belur. And this particular course will be suitable for the school children, and that is also developed in Bengali language, my own mother tongue, and it will be translated into other regional languages also very soon, so that this particular course for the school children, that is on robotics and artificial intelligence, in Bengali that is called Jantro Manav Nirman Vidya এবং Kritim Buddhimatta. So this particular course has been developed for 11 hours, and very soon it will come to the market, and it will be done by our Ramakrishna Mission Belur. And it will be translated into other regional languages, so that from all over India, all the regions, like the people, the students, the school children, they can get that particular flavor of robotics and AI. So with this, I thank all of you for your uh, patience and for listening to my lecture. And I'm once again thankful to all of you. And now the second part of this particular lecture, this will be taken by Mr. Bitan Pratihar. So he will be talking on how to use the principle of fuzzy set, fuzzy logic, fuzzy clustering to solve that particular problem of multi-sensor data fusion, and which is also used in robotics to collect information of the environment by taking the help of a number of different types of sensor. So this particular data is multidimensional data. The data is having some uncertainty and imprecision, and each of the sensor will have different ranges. So all such data are to be represented in the normalized scale. Then the data, different types of data, how to fuse together using the principle of fuzzy sets, fuzzy logic, fuzzy clustering, and how to use it to collect information of the environment, which will be useful by the robot. So I'm now requesting Mr. Bitan Pratihar, the research scholar here at IIT Kharagpur, and he is going to talk on the principle of fuzzy set, fuzzy clustering, and how to solve that multi-sensor data fusion in robotics. So with this, I request Bitan to start. Now it is handed over to Bitan. Bitani can start. Shall I?
Hello. Hello. Am I audible to everyone?
Yeah,
Yes,
yeah,
yes.
you are audible. You are
Yeah,
audible.
you are
You
audible.
just share that PPT file.
Yes.
Share the PPT file.
Acha, for sharing, Professor Pruthier has to stop the sharing. Then only
Yeah,
I will be able to share.
you are right, you are right. Just a minute. What to go your
You
screen
have to
is
click stop share, that red button.
red button stop share. Yes,
हाँ,
you are right.
okay.
ठीक है,
Right, right,
हाँ,
right.
ठीक है, go ahead. Yes, it is coming.
okay, so I would like to thank the Institution of Engineers for giving me this wonderful opportunity. So today I will be discussing fuzzy clustering. So in my talk, at first I will be introducing the concept of fuzzy sets. Then I'll be talking a few lines regarding fuzzy clustering, some common fuzzy clustering techniques such as fuzzy Siemens clustering, entropy-based fuzzy clustering, entropy-based fuzzy Siemens clustering, and in the end, an application of entropy-based fuzzy Siemens clustering algorithm. So at first, I like to give a brief introduction to fuzzy sets. So as we know,
Uh,
set,
Sorry to
yes,
interrupt, Bitan. Can you make it
huh,
slightly larger? This screen. Is there any possibility?
uh,
No, no. I think.
no,
ठीक
I am presenting it in the slideshow
अच्छा
mode only.
ठीक है, no problem. Go ahead, go ahead.
Uh, okay, so set is basically a collection of elements and a set with fixed and well-defined boundaries between the elements of the set and those lying outside it is termed as a crisp set or a classical set. However, if this boundary is imprecise or vague, then the sets are known as fuzzy sets. So the concept of fuzzy set was first introduced by Professor L.A. Jade of University of California, USA in the year 1965. So as we know that real world problems are generally associated with different types of uncertainties and that can be efficiently handled using the concept of fuzzy logic. To demonstrate that, I would like to give an example that has been shown in figure 1. So let us consider a case in which Mr. A asks Mr. B to bring some red apples from the market. So in this case, there are mainly two types of uncertainty. One is whether the apples are available in the market, and if they are available, then whether they are red in color. So the first uncertainty has the probability of zero or from 0 to 1, that is whether the apple is available or not. They can be easily solved using the principle of probability. However, for solving the second uncertainty, we may use either crisp set or fuzzy set. So if we use crisp set, then the color of the apple can either be red or not red. However, according to fuzzy set, the red can be defined using a membership function value. That means if the apple is perfectly red, that means the color of the apple is red with a membership function value of 1. Membership function value is nothing but the degree of belongingness. Also, if the color of the apple is almost red, slightly red, or not red, that means the apple is red with a membership function value of 0.8, 0.4, 0 respectively. So in this way, we can see that the uncertainty regarding the apple being red in color can be more suitably tackled using the principle of fuzzy sets. So fuzzy set is nothing but a general form of classical set. Now, clustering is a powerful tool of data mining in which the data are generally grouped into several clusters based on the similarity among them. Now, clusters can be either crisp or fuzzy in nature. So, when crisp clustering is done, then the clusters have well-defined and fixed boundaries. And a data can belong to only a single cluster. The common techniques used in crisp clustering are K-means clustering. However, for fuzzy clustering, the clusters have vague or imprecise boundaries. That means an A element can belong to several clusters with different membership values. And the common techniques used here are fuzzy Siemens algorithm, entropy-based clustering, and others. So if we see figure 2, we can see that in case of crisp clustering, we have a cluster 1, and the element, suppose if we consider this element, it belongs to only cluster 1. However, if using the same set of data, if we do fuzzy clustering, then we can see that this element belongs to cluster 1 with a membership function value of 0.7. And it may also belong to some other clusters drawn, suppose in this way, in a membership function value of say 1 minus 0.7, that is 0.3. So now we will be discussing some of the common fuzzy clustering algorithms. At first, the most common clustering algorithm is fuzzy Siemens clustering. It was proposed by Bezdek in 1973, in which an attempt was made to minimize the dissimilarity measure, which is expressed in terms of Euclidean distance of the data points with the predefined clusters. This algorithm is iterative in nature, in which the cluster centers and the membership values of the data points with the clusters are updated to minimize these dissimilarity measures. It is also important to note that the performance of this clustering algorithm depends on the type of data set and the initial membership values that were selected at random initially. So it will be discussed in detail in the next slide. So for all the clustering algorithms, we will be using the same type of data set. That means the data set will contain n number of data points represented by xi, and each of these data points will have L number of dimensions. It has been pictorially represented in figure 3. Now let us discuss the algorithm for fuzzy Siemens clustering. So at first, the number of clusters to be made is fixed, and this is denoted by C. The value of C, that is the number of clusters, varies from 2 to n. N means the total number of data points. Next, we select the appropriate level of cluster fuzziness, that is G, and its value is greater than 1. Next, we initialize the n cross C membership matrix mu, where the elements are mu ij, and mu ij means the membership value of ith element with the jth cluster, and it belongs to 0 to 1. Also, for each I, that means for each data point, the summation of mu ij, that is membership function of that ith data point with jth cluster, and the summation of from j equals to 1 to the total number of clusters is equals to 1. So next we calculate the kth dimension of the jth cluster center using which is denoted by ccjk, and it is equals to summation I equals to 1 to n mu ij to the power g xik by summation of I equals to 1 to n mu ij to the power g. Next, the Euclidean distance between ith data point and jth cluster center is calculated using this formula, that is dij equals to norm of ccj minus xi, where ccj is nothing but the cluster center and xi is the data. So the distance between them is calculated. After that, based on this calculated Euclidean distance dij, we update the membership fuzzy membership matrix. That is, if dij that is the distance between ith data point and jth cluster is greater than 0, then mu ij is updated to be 1 by summation m equals to 1 to c dij by dim to the power 2 by g minus 1. Also, if the distance between the data point and the cluster center is equals to 0, that means mu ij is 1, which in turn denotes that that point is that data point belongs to that cluster only. Now we repeat step 4 to 6, step 4 to step 6 until the change in mu between two consecutive iterations is less than some pre-specified value. After that, we group the data points into clusters based on the value of this matrix mu. Now let us look to another type of fuzzy clustering, that is entropy-based fuzzy clustering. In entropy-based fuzzy clustering, entropy is calculated for each data point based on a similarity measure, which in turn depends on the Euclidean distance. The data with minimum entropy value is selected to be the cluster centers, and the data points having similarity with these cluster centers more than some pre-specified value will form a cluster. So the algorithm is as follows. At first, we take the same data set as discussed earlier. It will be a data set matrix T, which has n number of rows and L number of columns. Next, we calculate the Euclidean distance between the data points, between two data points, xi and xj, using this. After that, the similarity between these two data points are determined using Sij equals to e to the power minus alpha dij, where alpha is a parameter and Sij generally varies in the range of 0 to 1. After that, we calculate the entropy of data point xi with respect to all the other data points using ei equals to minus summation j belongs to x, j not equals to I, Sij log Sij base 2 plus 1 minus Sij log 1 minus Sij base 2. After that, we identify the data points having the minimum EI value, that means the minimum entropy value, and select it as the xi mean, that means the cluster centers. Now we put xi mean, the cluster center, and the data points having similarity with this cluster center greater than beta, which is a threshold value of similarity in a cluster, and remove them from this matrix T, the initial data matrix T. After that, if T is empty, then we terminate this whole algorithm. That means it has always all the data has been clustered. Else, we go to step 5 and repeat the same. Now, there are some limitations in both of these above discussed clustering algorithms. That means fuzzy Siemens clustering, the clusters are compact, but they are less distinct. However, and in entropy-based fuzzy clustering, the clusters are distinct but less compact. So, in order to rectify this disadvantage, we combine the principles of both fuzzy Siemens clustering and entropy-based fuzzy Siemens clustering, where the cluster centers are determined from the data set as done in entropy-based fuzzy clustering and iteratively improved as done in fuzzy Siemens clustering. So this method is generally known as the entropy-based fuzzy Siemens clustering, which employs both the principles of fuzzy Siemens clustering as well as entropy-based fuzzy clustering. So the algorithm is as follows. We start with the same data set having n rows and l columns. Next, we calculate the entropy of each data point with respect to all other data, just as we do in entropy-based fuzzy clustering. After that, we identify the data having minimum entropy values and consider it to be the cluster center. The cluster center and the data points having similarity with this cluster center greater than beta is then considered to be one cluster. Then we remove it from this matrix T. If T is empty, we terminate the program, else go to step 4. So in this way, we will get a number of clusters. After that, we will use the principle of fuzzy-Siemens clustering. That is, we will calculate the Euclidean distance of the ith data point with jth cluster centers. These cluster centers has already been determined using entropy-based fuzzy clustering. So after getting this Euclidean distance, we will update the fuzzy membership matrix mu. This has already been discussed in fuzzy-Siemens clustering algorithm. We will modify the coordinates of cluster centers that is CCJK, and we will repeat step 6 to step 8 for a predetermined number of iterations and group the data into clusters based on the value of mu. So this will take the advantages of both the above mentioned algorithms and will help to form both compact as well as distinct clusters. So in order to demonstrate this algorithm, we will be taking one example. So this is an application in which we have done the classification and prediction of cardiovascular autonomic neuropathy severity using fuzzy logic based expert system. So cardiovascular autonomic neuropathy, also known as CAN, is basically a complication, a serious complication of diabetes. And we have collected the data, and we have seen that we saw that the severity of can be either normal, early, or severe, and this generally depends on a number of characteristics of the patients. That means that the CAN severity generally depends on some of the characteristics of the patients, such as age, duration of diabetes, etc. So here we can see that there are total 9 characteristics. So from this table, we generate a data, we generate some 200 data points of 200 patients, in which there will be 200 number of data points. That means n equals to 200. And each of these data points will have the values of all the characteristics. That means the dimension of each data points will be 9. That is, L will be equals to 9. So we are taking a higher dimensional data where the number of rows is 200 and the number of dimensions, that is L, is equals to 9. So for better visualization of this 9-dimensional data, we will use a Salmon's nonlinear mapping technique and map this data in 2D. And this mapped 2D data can be seen in figure 6. This mapping is very important to extract useful information as well as to visualize this higher dimensional data in a 2-dimensional space. Next, this 2D mapped data is then clustered using the principle of entropy-based fuzzy-Siemens clustering, and we can see in figure 7 that 3 compact and distinct clusters denoting each type of severity, that is normal, early, and severe, can be constructed. So using the principle of entropy-based fuzzy-Siemens clustering, we will cluster this 2-dimensional mapped data, and after that we will get 3 compact and distinct clusters. Using the information of cluster centers of these 3 clusters, we will train a fuzzy logic based predictor. This fuzzy logic based predictor will utilize the data set as well as the information of these cluster centers and will help to predict the output. In our case, the predicted output is basically what is the severity of CAN. So in this, we will take the information regarding the characteristics of the patient and will try to predict whether the cardiovascular autonomic neuropathy of that particular patient is normal, early, or severe. So this is nothing but a multisensory data fusion algorithm which may also be used in robotics, in which this higher dimensional data will be collected from various sensors by the robot, and they will be used to predict a certain output, for example a movement or something like that. So thank you, very much.
Okay. Mm. So,
So thank you
Vedant,
very much,
ah,
Bitan, our
Yeah,
future
thank
prominent
you.
engineer come scientist, and Dr. Dilip Pratihar, a dedicated person in AI and robotics, needs no introduction.
thank
Now
you
we
very
got
much.
an
Thank you
excellent
very much.
presentation on the both the subjects. Lot of questionnaires got developed today, and
Okay.
it's a really exciting that the so many questions got popped up, and I will
Mm.
be taking one by one questions. Uh, One person asked, why is AI and robotics important to India?
Okay. Okay. So can you hear me?
Yes, yes, yes.
Yes. Now, as I discussed that in robotics there are four modules, and the aim of robotics is what? To replace human being by a robot. And I'm just going to discuss what do you mean by replacement. Okay. Now, before that, let me tell you that if you want to use a robot in place of a human being, the robot has to be made more or less equivalent to a human being in terms of thinking, in terms of activity. So, all the qualities of a human being ought to be artificially injected to the robot. Okay, so by doing that, for example, say in hazardous place like nuclear power plant, or say robotic soldier, or there is one fire hazard, so there we do not want to put the human operator. Okay, and those human operator will be replaced by the robotic operator. Now, unless this robot is capable of performing like a human being, we cannot replace that particular human being by a robot. So, robot has to be designed and developed as if that is equivalent to a particular the human being. Now, as you asked that in India whether this particular concept will work or not, now, these particular questions I have faced several times. You think about the productivity. What is our aim? Our aim is to increase the productivity so that our production for the whole country, say whole India, it improves and its GDP improves. So if GDP improves, we'll be getting the fruits of that particular improvement in GDP, all of us. So don't think that this particular robot is going to make one human being unemployed. Okay. So what you can do is using the robot, we can improve the productivity, and we are getting some improvement in GDP. And along with the robot, if one human operator, the same human operator, if he works, so what will happen to the level of production or the productivity? So it is bound to improve, bound to increase. So we are not really replacing a human being, or we are not actually taking the job of a human being. Like in place of that, we are taking the help of a robot, assistance of a robot along with the human being to improve the productivity, to improve the GDP of our country. So I hope I'm able to give a reply to the query, and particularly the concern is the India, country like India, whether it makes sense or not.
Thank you, Dr. Pratik. There is another question is that, is there any, in the medical surgery is happening with applied AI technology?
Yes, there are
And
many.
yeah, there are a lot many robotic surgeries and
Yes, yes,
remote
yes,
surgeries are being happening.
yes,
And with
yes,
the advent of 5G, it's getting properly
yes, you are
happening.
right.
Now, my
You are right.
question is, are they successful in flawless operations?
Yes, yes, I'll tell you a few operations. or a few applications of robots in medical science. Okay. Now I'm just going to tell you one after another. The first one is the telesurgery. As all of us we mentioned about telesurgery. So telesurgery with the help of a robot is such a condition where the patient is there might be 10 kilometers away from the doctor, and there are two robots. One is the master robot, another is the slave robot. The master robot is used by the doctor sitting might be at a distant place of 5 kilometer, 10 kilometer away from the patient. And the slave robot is actually carrying out that particular operation on the patient. And the tools for the surgery, like knives, then comes your scissors and others, needles and others, those are actually gripped by that particular the slave robot. And with the help of this wireless communication, so the doctor is able to give some sort of instruction with the help of the main robot to the slave robot, that you carry out this particular set of operation one after another in a particular the sequence. Whenever a doctor, a human doctor, carries out operation, he or she does a set of operation in a particular sequence. The same set of operation in that particular sequence has to be done by that slave robot, and that will be instructed by the main robot, by the doctor. The doctor is going to give all the instruction to the slave robot through the main robot. That is called actually the telesurgery. Now with this particular the 5G, 4G, even 5G, things will be even better. So it can be done very accurately. There are a few other applications also. Now some of the robots are developed in a very small size, just like your tablet or a capsule. Okay, and this particular capsule robot is nothing but a multi-legged robot. So the way we take the medicine tablet capsule with the help of water, so we can swallow. Now this particular capsule is nothing but a multi-legged robot having some camera inbuilt. So it will start working on the stomach, and it will take the snap at a regular interval. And using this wireless technology at a regular interval, so we'll be able to collect the image or the picture of the possible location of the tumor or any other problem inside that particular the digestion system. This is another application. There are a few others. For example, we also developed your orthotic device, the supporting device, or the prosthetic device like the artificial limbs. These are also coming under the umbrella of rehabilitation robotics. And there, without using the principle of AI, in fact, we cannot utilize these robots in medical science. Okay, so I think I could make it clear. It seems.
Absolutely, Dr. Pratihar. There are a lot of questions, but only 2 minutes are left. So to have a justice to the time, we'll take only one question. Sorry to everyone, but what we can do is that we'll take all the questions and then we'll send to Dr. Pratihar and we'll get the answers and we'll give you back.
I have got another suggestion.
Okay.
I have got one meeting, IEEE meeting at 7:30. Okay.
Yeah.
So
Yeah.
I'm available up to 7:15. So no problem.
Okay.
If you are okay from your side, if it is okay.
Actually, we have to close early. Actually, this link has to be given to others. Right.
Okay.
Thank you, Dr. Pratihar. So what I will do is that I will pass all the questions to you, and then the questions that after getting the answers from you will pass on to all the team. Right.
Okay. Okay.
And we'll take the last questions today. Is that Dr. Bhaskaran has given a very interesting question. Why 25 DOF humanoid is not used much as soldier in the army?
Pardon?
Why 25 DOF humanoid is not used much as soldier in army?
Yes, this is very interesting. If you see our human body, human body has got more than 63 or more than 60 mobility levels. Truly speaking, we roughly say it is degree of freedom, but by definition of robotics, degrees of freedom cannot be more than 6. The reason, there is a reason, okay, because a 3D object in 3D space has got 6 degrees of freedom, 3 for position, 3 for orientation. So a robot can have actually only up to 6 degrees of freedom. So whenever we say it is 25 degrees of freedom, it is actually 25 mobility levels of mobility. That is a better way of talking. Now we human being, we have got more than 60, 63 plus. It varies from person to person also. So many such mobility levels. Okay. So this 25 degrees of freedom, the so-called degrees of freedom humanoid robot will not be able to perform its duty in the real field. So what we need is more than 60 degrees of freedom. And I'll tell you, if you allow me to tell you the complexity of its calculation. Now, Mr. Chakraborty, I can pass one information. See, the dynamic modeling of the 7 degrees of freedom biped robot, actually it is done by us only first in the world. Okay, in the year 2007, it was done in my lab and I took the initiative. That is the first study on dynamic analysis of 7 degrees of freedom humanoid robot, or the biped robot rather. It is so complex, its top calculation was, still I remember, 100 printed A4 size pages according to Lagrange Euler formulation. Now we got that Indo-Canadian fellowship. There we got a problem of 29 degrees of freedom humanoid robot. That analysis also we carried out and we completed the project in 2021. We know the complexity. And moreover, as I mentioned, that if you go for the multibody dynamics analysis, that will be even much more complicated. Are you getting my point? So carrying out dynamic analysis for a humanoid robot having 60 or 63 degrees of freedom, it is quite difficult. You can say it is impossible. Now you may ask, how does our human body works? Remember, our human body works based on the principle of evolution of our brain, not through explicit design of our brain. Okay, the main problem which we are going to face is maintaining the dynamic balance of the body. Power consumption is one, but more important thing is how to maintain the dynamic balance of human body, whether it is the human body or it is the robot. Okay, so that is why actually this 26 mobility levels of now robot cannot be used directly in the real field. Some work is going on. I'm not going to tell you because I cannot pass that particular information as on today, but some work is going on how to develop more mobility levels humanoid robot which can be used in fields also. I'm sorry, I'll
Thank you.
not be able to pass that information now.
No, Dr. Pratyar, thanks for all the giving all the intimation. So now I invite Mr. Ramchandra Chakraborty to give the vote of thanks.
Good evening, dear audience. You have made our evening bright and beautiful. This is our 24th webinar, and at least we received more than 600 registrations, and we got 128 participants, and we got reactions from the participants, 43 reactions, comments, questions, or whatever queries. So it shows the popularity of Professor Dr. Deepak Kumar Pratyar as an expert on AI and robotics. Thank you very much, sir. Thank you, Bitan, for your kind presence and for illuminating and giving a wonderful exposure to our learned audience. Thank you very much for everybody, and we look forward to meet you once again in the month of November for our 25th monthly webinar. Thank you very much. Wish you a pleasant evening.
Thank you very much.
And rest of the weekend.
Thank you.
Thanks,
Thank you
Ramda.
very much.
Thanks, Dr. Pratihar.
Ah,
You
So
came
nice of
with
you.
a very small notice. And thanks, Bitan.
mm,
Thank
We
you, sir.
wished your
Thank you.
speedy completion of your PhD work.
Thank you, sir.
Thank you very
Thanks,
much.
Because of
thanks,
Durga
thanks.
Puja, we had to prepone it in the middle of the month. Normally, we go for the last Saturday of the month, but this time, Durga Puja festival, Lakshmi Puja, and other things, Bengal. So
Yeah,
that
yeah,
way,
yeah, yeah. Yeah,
that's why we have to
Yeah.
put in the middle of
Dr.
the month. Thank you very much.
Dr. Prothiar is well aware about this thing.
Yeah,
yeah, yeah, yeah.
for a part of the audience, of we have 47 queries from the customer, and as of now, 82 participants are still logged on. So this shows the
Okay,
popularity of
good,
Dr.
good, good.
Prothiar.
No, thank you very much. I really enjoyed. Although in a small time, I had to actually discuss many things in a hurried way,
Yes, sir.
but I tried. But all the things actually you'll have to go to the depth and see. That will take long time.
Yeah,
Yeah,
absolutely,
naturally. We are
absolutely.
allotted 2 hours time and totally to
Yeah,
complete
yeah.
this because our people has to, I mean, leave the office because still they are in
Mhm.
the
Yeah,
office.
yeah,
They will
yeah,
have to leave
So,
yeah.
Saturday.
Dr.
So,
Prothiar, sometime we'll extend this lecture to the, the next session sometime, and we'll make the part 2 of that.
Okay, thank you. We'll see.
thank you, sir. You structured
Okay,
Okay,
your
thank you,
presentation
sir.
so beautifully. We have all
thank you.
learned from your presentation. You're so
Thank you
lucid,
very much.
so
Thank you very
simple,
much.
so
Thank you.
practical, and so full of wisdom.
Uh,
Thank you
you.
very
Thank you
Thank
much.
so
you.
much. Thank you,
Uh,
sir. Thank you.
okay,
Thanks,
bye.
thanks.
Bye.
Thank
Thank
you.
you,
Bye.
thank you. Thanks, Bitan.
Mm, mm.
Thank you.
Thank you. Thank you.
Thanks.
Dr. Kingshuk Sen, you may please close the session.
Sir, thank you, sir.
Thank you very much for your kind help and support.
Dr. Sen, one kind request is to trap all the questions so that we can send it to Dr. Pratihar, right?
Okay, sir. And before closing,
Okay, thanks.
taking the copy.
Right. Thank
So,
you.
sir, with your kind permission, we are now closing the session. And,
Yeah, please.
all the participants, it's an announcement that our e-certification link is open till tomorrow midnight. So those who want to have their e-certificates, please apply for it for this wonderful session and have your certificate with 300. Thank you.
So
Yeah,
wish
this will be effective certificate.
wish everyone happy Durga Puja.
Sir. Thank you.
Thank you.
Okay.
Thank
Happy
you very
festive
much. Same to
season.
you.
Okay.
Okay, thank you, sir. Thank you so much.
Okay,
Bye.
thank you.
Thank you.
Thank you very much.